All right, guys. So our goal today is to be able to start doing our heat problems. Last class period or the last video, I introduced our chemical equations that we generally use with heat. So we have two different equations, and then our goal today, like I said, is to be able to use those equations, okay? So let's look at this worksheet here. This is one of our worksheets that we've got. And I'm going to go through this first question here, okay? So the equation that we're going to use is Q equals mCAT, okay? So we have, if we read this question, 5 grams of copper was heated from 20 degrees to 80 degrees. How much energy was used to heat copper? Okay, so if we look at number 1 here, right, we are going to use Q equals mc delta T, okay? So I'm going to rearrange this a little bit and say rather than delta T, I'm going to call delta T T final minus T initial. Okay, so let's identify in here what we actually know, right? We know the mass, that's going to be 5 grams of copper. So M equals 5 grams of copper. We know T initial and T final. So T initial equals 20 degrees C, T final equals 80 degrees C, and then we're given the specific heat capacity for copper, okay? So in our equations the other day, I gave us the specific heat capacity for water, right? If we have liquid water, if we have ice, if we have water vapor, but again, it's specific to each different compound, so we are given that in this question, okay? So that C value is going to be 0.386 joules per gram Kelvin, okay? So we have this, all of these here. We're asked, right, how much energy was used to heat copper. So the question mark is going to be Q, right? Anytime we see these questions, right, we want to identify each of those pieces of information that we know, and then we want to identify what are we actually trying to calculate, okay? So this is a general skill for us to learn, okay? So we read this question, we realize, okay, we want to get the energy used to heat copper. Well, that's going to be Q. We have each of our other pieces within our equation, Q equals mCAT. So let's plug those in. So Q is going to equal 5 grams of copper. That's my M. C, 0.386 joules per gram Kelvin. And then delta T, right, we're using T final minus T initial. So T final was 80 degrees C minus 20 degrees C. Okay, so we plugged in each of our values into this equation. Now we just need to calculate what it is. We have grams of copper canceling with grams. We have Kelvin on the bottom, and degrees C, right, we have a change in degrees C. Well, a change in degrees C, we know that change in degrees Celsius is the same as the change in temperature in Kelvin, okay? So Q is going to equal 5 times 0.386 times 80 minus 20 would be 60. We're going to use 115.8 joules to heat up our copper, okay? Now sometimes, of course, we're going to solve for something else. Maybe we know the heat, and maybe we need to solve for the mass, or C, or delta T, right? One of our T final or T initial. So we can solve for those as long as we have all of our other variables, okay? So in this question, we only had one variable here, okay? If we only had one variable and we had all of our others filled in, we were able to solve for Q, okay? So all of the questions on this page use Q equals mCAT, All right, so we should be able to kind of work through these, but we may need to rearrange our questions, okay? Or we may need to rearrange our equation to solve for the correct variable, okay? All right.